Homework 29 says factoring a quadratic with a leading coefficient of 1. Quadratic expression just means it's a second degree polynomial. The highest exponent is a 2, so it has that squared term in it. W squared minus 9W plus 20. When I got quadratic expressions, it came from FOILing something out. We did that multiplying binomials, and we got answers that look like this. Now on ALEKS, when they have you do this, they're going to have some weird, crazy explanation that I really don't like. So I recommend on ALEKS that, let me close this here, if we go to our stuff, got to get back to my student view here. If you go to the explain on factoring a quadratic with leading coefficient of 1, you have this ALEKS explanation with this big old long table. If you go over to the side, there's resources from your instructor, me. It says Linda's Notes E31. If you click on that, it's going to download that, and you can bring up that Word document that gives you my directions on how to do your factoring. These are what I'm going to do. So you will probably want to print that out and keep that with your stuff. I'm going to close that. The other place that you can get your notes is if you go under the resources. Now if you go under the resources, up there on the top, all of the notes I've uploaded are here by chapter. We're on chapter 4, but they're numbered the same way as your paper. This one said it was E31, so you'd have to go down to E31. And E31 then would give you Linda's Notes. And again, you could download that. It's not going to like me because I've just downloaded it the other way. But just click on that and you can download Linda's Notes E31. Going to give you the directions for factoring in case it's not quite on your pie chart yet. So either under the explain or under the resources, you can get my notes on how to do this. Now we'll go to how I'm going to do this. So on my notes it says if I'm going to factor my quadratic, it came from FOILing something out, so I'm going to have 2 sets of parentheses. And the first thing I'm going to do is factor this leading term. What times what gave me W squared? Well, to get W squared, I had to have a W and a W. W times W is W squared. The second thing it's going to do is to tell you to figure out the sign. So when you figure out the sign, you're going to look at the end sign. If the end is a positive, you're going to either have a positive and a positive or a negative and a negative. It will be the same as the middle. I should probably put the both of them are the same as the middle because they're both either positive or both either negative. So what I do when this is positive is I look at my middle sign. It's a negative, so I know that a negative times a negative gave me that positive, but still added up to the negative in the middle. Then what I'm going to do is factor the end number. My factors are 20. 1 and 20, 2 and 10, 4 and 5. I want the pair of factors that when I do the outside plus the inside, in other words, when I add them together, I get this middle number. Well, in this case, 4 and 5 add up to 9. A minus 4 and a minus 5 would add up to minus 9. So my answer here is that I have W minus 4 times W minus 5. If I wanted to check it, I would FOIL it out. W times W is W squared. W times a minus 5 is a minus 5W. Negative 4 times W is a negative 4W. Negative 4 times a negative 5 is a positive 20. Those two middle terms, the outside plus the inside, have to add up to the middle number here, the minus 9W, and it does, so it checks out that that's my answer. When you enter it in, yes, you do need the parentheses, so W minus 4 in parentheses times W minus 5 in parentheses. And that's going to be your answer. So the second one there tells me to factor. It's a quadratic trinomial, means I'm going to have 2 sets of parentheses. Factors of x squared. X and x. Looking at my sign, again my end sign is a positive. If my end is a positive, I know it's either going to be both pluses or both minuses, the same as whatever the middle is. The middle is a plus. So it's a plus and a plus. A positive times a positive gives me a positive on the end and adds up to a positive in the middle. Now I'm looking at the factors of the end number. The factors of 64. 1 and 64, 2 and 32, 3 doesn't work, 4 goes in there, 24, 16 times, 5 wouldn't work, 6 wouldn't work, 7 doesn't work, 8 does. 8 times 8 is 64. I'm looking for the pair of factors that's going to give me 20 in the middle. So the pair of factors here that would give me 20, 4 and 16. If I check, my outside product would be 16x, my inside product is 4x, those add up to the 20x in the middle. So my answer, x plus 4 times x plus 16. Now the third one tells me to factor. Again, it's a trinomial, so I know that I have 2 sets of parentheses. Factors of y squared, y and y. This time my end is a negative. If the end is a minus, I'm going to have 1 plus and 1 minus. A positive times a negative is a negative. Again, I'm going to factor my end number, 1 times 6 or 2 times 3, but this time, since my signs are opposite, I have to subtract them to get the middle number. I'm really technically adding, but when you add opposites, you subtract. So I think about it this way. Okay, which pair do I subtract? I want to get a minus 1. So if I'm going to do that, 2 minus 3 is minus 1. I need a plus 2 and a minus 3. 2 minus 3 is minus 1. Again, if I wanted to double check, I'm thinking about foiling, taking the outside plus the inside. So the outside pair gives me minus 3y, the inside pair gives me a positive 2y, and sure enough, negative 3y plus 2y is the minus 1y you want in the middle. You could FOIL the whole thing out, but just as a quick check, the outside plus the inside have to be the middle. And so y plus 2 times y minus 3 is my answer. Once we get to 4, 5, and 6, we're factoring a quadratic with a leading coefficient greater than 1, which makes it a little more tricky because we have to think about the outside plus the inside being the middle. So again, I know I'm going to factor. I'm going to have 2 sets of parentheses. I want the factors of 2x squared. 2x squared. What times what gives me 2x squared? Well, 2 times 1 is 2, so I would have to have a 2x and an x. You could put the x first and the 2x second. It really doesn't matter, just so you have a pair that works to give me 2x squared. So 2x times x is 2x squared. Now my rules for my signs are the same as the rules we did on the first 3. The end is positive. We said if the end was positive, they were either both pluses or both minuses. We looked at the middle. The middle is a plus, so they're both pluses. Now we want the factors of 30. 1 and 30, 2 and 15, 5 and 6. Now this one's a little tougher because I can't just add or subtract them to get the middle number because I have to think about foiling. So what I want to do basically is just guess and check. Normally I'm just going to start with the bottom pair and plug them in. So I'm going to put the 5 and the 6 in, and then I'm going to check them. 2x times 6 would be 12x. 5 times x is 5x. 12 plus 5 is 17. I want 19. Not going to work. So what I'm going to do is switch the order around and try it the other way. 6 and 5. Grab my eraser again here. And now I'm going to check. 2 times 5 gives me 10x. 6 times x is 6x. 10 plus 6 is 16. Still doesn't work right. And you could be doing this in your head, but just to explain what I'm doing, I'm writing everything down. So now I go to the next pair, the 2 and the 15. So I'm going to put the 2 and the 15 in there. 2 times 15 is already going to be 30, so I know the 15 can't go there. I'm going to try the 15 here and the 2 here. 2x times 2 is 4x. 15 times x is 15x. And sure enough, after all that guessing and checking, I finally got to the 19, so I know that that has to be my answer. And again, if I really wanted to, I'd go through the whole process of FOILing. 2x times x is 2x squared. 2x times 2 is my 4x. 15 times x is my 15x. 15 times 2 is my plus 30. And my 2 middle terms add up to the 19x in the middle. So it checks out, yep, I've got the right 2 pair of factors. So it's kind of a matter of guessing and checking, knowing what my factors of 30 are, and plugging them in until I find the right pair that gives me the 19x in the middle. And the more you do, the easier it gets to recognize what you should use. Number 5 tells me to factor again. Again, I've got a quadratic expression because it has a squared term. Trinomial, 3 terms in there, came from FOILing. The problem with this one is 6x squared. 6x squared could be 6x times x, but it might be 3x times 2x. You really don't know what pair it is. A lot of times I'll just put both of them down. Is it 6x times x or is it 3x times 2x? I don't know. I just have to guess and check. The more you do it, the easier it gets. Excuse me. My rules for my sign. Again, the end is a positive. If the end is a positive, both signs have to be the same as the middle sign. So in this case, we have a negative and a negative. Factors of 2. Fortunately, there aren't a whole lot of factors for 2. It's either 2 times 1 or 1 times 2, right? So then I'm going to put them in and check. My outside product would be negative 6x. My inside product would be negative 2x. That adds up to negative 8. Here, if I try it this way, my outside product would be negative 3x. My inside product is negative 4x. Well, that's negative 7x. Still not what I want. So I know neither of those are right. So now I switch it around. 1 and 2 instead of 2 and 1. And like I said, a lot of times I just check in my head instead of writing it down, but so you can see what I'm doing. 6 times negative 2 is negative 12x. Negative 1 times x is a negative 1x. Oh, there's my negative 13x. I know that's the pair I want, but just for fun I could check the other one. 3 times negative 2 is negative 6x. Negative 1 times 2 is negative 2x. Oh, that one's only negative 8x. So that's the only pair that works out to give me that negative 13x in the middle. So it's just a bunch of guessing and checking. Again, if you look at Alex, they'll have this great big long table with P's and Q's, and eventually they get to all these different choices. But really all you're doing is plugging them in and checking out, well, which pair gives me this middle term? So number 6, when I factor that, I wonder if that was supposed to be a plus or a minus 20 because she has plus a negative 20. Let's fix that. I think it's probably the minus 20. Clear that. So make that 3y squared plus 28y minus 20 if it's not already fixed on your printout. Again, we're factoring. Factors of 3y squared. Well, for 3y squared, we only have 3y times y since 3 is a prime number. 1 times 3 is the only way to get 3. This one, we have a minus on the end. When we have a minus on the end, it means that it's either a plus and a minus or a minus and a plus. We don't know which order they go in. When you don't have the coefficient, the number in front, you don't have to worry about which order you put them. But if you do have a number in front, then you have to think, oh, it could be one way, but it might be the other way. So again, I'm just going to write them both down for now, and then I'm going to start checking. Factors of 20. 1 and 20, 2 and 10, 4 and 5. I always like to start with the pair that's closest together, so I'm going to try the 4 and the 5. My outside product is negative 15y. My inside product, positive 4y. That's not going to give me the right answer. Here, my outside product is 15y. My inside product is negative 4y. Notice my numbers are the same, just the signs are different. This one gives me a negative answer, and this one gives me a positive answer. Still not the right answer, but it is positive. So that tells me that probably I'm not going to use this one. I'm going to use this one and switch my signs or my numbers around and try it that way. So here, my outside product gives me 12y. My inside product gives me negative 5y. Well, 12 minus 5 still isn't 28. So I try my 2 and my 10. If I put my 2 and my 10 in there, 3y times 10 is 30y. Negative 2 times y is negative 2y. Oh, there's my positive 28y that I wanted in the middle. So after a bunch of guessing and checking, I find that 3y minus 2 times y plus 10 is going to be my answer. Now the next ones, we're doing the same thing. We just have variables with both of our numbers. And so we have 5x squared minus 3xy minus 14y squared. We're basically still doing the exact same thing. We know it came from foiling. Factors of 5x squared. 5x and x. My signs. If the end is a negative, I know I have one of each. Now normally I don't write them both down. I just put a plus and a minus. If I get the correct middle number but the wrong sign, I switch my signs the other way, because then I know the minus has to go first and then the plus. So I'm going to just plug them in one way, unless you want to do it both ways. And then I'm going to do the factors of negative 14y squared. So it could be 1 and 14, or it could be 2 and 7. I'm going to start with the 2 and the 7, but they have to have y's. So 2y and 7y. 5 times negative 7 would be negative 35 plus 2. Negative 35 plus 2, definitely not negative 3. So I'm going to switch them around. 7y and 2y. 5 times negative 2 is negative 10y. 7y times x is going to be 7xy. And so here, negative 10xy plus 7xy is negative 3xy. My sign is correct, my number is correct, so my factoring is correct. 5x plus 7y times x minus 2y then. Number 8, I'm factoring again. I'm going to have my 2 sets of parentheses. This is a trickier one again because I don't have a prime number in front. 4x squared could be 4x times x, but it might be 2x times 2x. And again, I'm just going to start with the 4x and the x. If that doesn't work at all, I'll have to go to the 2x and the 2x. My end is a positive. My end is a positive. I know I have either both pluses or both minuses. I look at the middle, tells me they're both minuses. Factors of 6y squared, so 6 and 1 or 3 and 2. Again, I got to make sure I put the y with those. So I'm going to put 3y and 2y. I'm going to check it out. My outside product gives me negative 8xy. My inside product gives me negative 3xy. And I was good at guessing on this one. A negative 8 plus a negative 3 is negative 11. So 4x minus 3y times x minus 2y is my solution. Number 9, still factoring my quadratic trinomial. Came from foiling. Factor my first term. 2x squared. The only way to get 2x squared 2x times x, or x times 2x, whichever order you want to put them in, it doesn't matter. The end is a negative. Excuse me, if the end is a negative, I have 1 plus and 1 minus. I don't know which way they go. I'm just going to plug them in. I'm going to get a quick drink here. Factors of 21y squared. 21 would be 1 times 21 or 7 times 3. Excuse me. I'm going to start with the 7y and the 3y, and then I'm going to check. My outside product is negative 6xy. My inside product is positive 7xy. Man, I'm a good guesser on this one. Negative 6 plus 7 is a positive 1xy, and that's what I wanted, a positive xy in the middle. So 2x plus 7y times x minus 3y is going to be my solution. Excuse me. Number 10 says factoring a perfect square trinomial. Trinomial, again, it has 3 terms. Again, it's still a quadratic expression. And when you do these on Alex and on the assessment, you're probably not going to know which one of these factoring ones it is. So you just factor it the same way as you've been factoring it all the rest of your trinomials. I'm going to have 2 sets of parentheses. We're back to not having a coefficient in front of our v squared. What times what is v squared? V times a v. Same rule for the signs. If the end is a positive, they both have to be the same. Since the middle is a negative, they both have to be negatives. I want my factors of 4 that add up to the negative 4. 1 times 4 or 2 times 2. Well, when I plug them in, 2 and a 2, right? A negative 2v plus a second negative 2v is the negative 4v in the middle. Now, the reason they call this a perfect square trinomial is you can see when you factored it, you got the same thing twice. So when you enter it in, they're going to have you enter it in as a square. V minus 2 times V minus 2 is the same thing as V minus 2 squared. There's my perfect square trinomial. But on the assessment, you probably won't know that's what it's going to be. So you just factor it the normal way. Here, we're factoring V squared plus 2V plus 1. So again, our 2 sets of parentheses, factors of V squared, V and V. The end is a positive, so both of my signs have to be the same as whatever the middle is, plus and a plus. Factors of 1 that add up to 2. Well, guess what? The only pair of factors for 1 is 1 and 1. If I take a 1v plus a 1v, sure enough, it adds up to 2v. The outside plus the inside adds up to the middle. I get a perfect square, so v plus 1 squared is what I'm going to put in for my answer. Number 12, same kind of thing. I'm factoring. Factors of u squared, u and u. The end is a positive, which means both signs have to be the same as the middle. Negative and a negative. Factors of 49, 1 and 49 or 7 and 7. Which pair adds up to 14? Well, the 7 and the 7 do. Negative 7 plus negative 7 is the negative 14 in the middle. U minus 7 squared is then going to be your answer. The next factoring says factoring a difference of squares in one variable. Difference of squares was a unique situation we got when we multiplied conjugates. If you remember when we did foiling, you had one that said multiplying conjugate binomials. And when you did that, you got the difference of perfect squares. Now again, you're probably not going to recognize, or maybe you will on this one because this one only has 2 terms and not 3 terms. But when you do this, it came from foiling something out. Factors of z squared, z and a z. The end is a negative. Since the end is a negative, you know you have a plus and a minus. Factors of 9x squared. Well, the key here is that you want to get 0 in the middle, and if I'm going to get a 0, I have to add and subtract the same number, opposites, right? Well, 9 is a perfect square. You get 9x squared by taking 3x times 3x. So when you FOILed this out, the outside was negative 3xz, the inside is a positive 3xz, and those canceled out, and that's why you didn't get that middle term. And so when they say conjugates, they mean the same terms with opposite signs in the middle, and you end up with the difference of perfect squares when you multiply conjugate binomials. So number 14, if you recognize that those are both perfect squares, 9 is a perfect square, 4 is a perfect square, that it came from FOILing factors of 9, 3 and 3. The sign is a negative, so a plus and a minus. Factors of 2x squared, but you have to use the pair that's the same, 2x and 2x. So that you get a minus 6x and a positive 6x when you FOIL, which is the 0 x's in the middle. And so 3 plus 2x times 3 minus 2x would be your answer. And the last one, number 15 here, again, we're just factoring. If you look at it, it's the difference of perfect squares. You're going to only have a few things where you have 2 terms instead of 3 terms. So you look, are they both perfect squares? Yes, they are. Factors of 49x squared, you'd want to use the 7x and the 7x. My signs, 1 plus and 1 minus. Factors of z squared, z times z. So 7x plus z and 7x minus z would be your solution. And any of these ones that say factor, if you multiply them back out, you should get what you started with. So if you're not sure if you did them right, FOIL it out the long way and check to see, does it work out? 7x times 7x, 49x to the second power. 7x times a minus z, minus 7xz. Positive z times 7x, positive 7xz. Positive z times a negative z, minus z to the second power. These are opposites, they cancel out, so I get 49x squared minus z squared. Yep, that's what I started with, it checks out. So you can always FOIL it back out and double check to see, does it work? And that's the end of homework day 29.